Good morning, everyone. Thanks for joining in. It is the morning session, and I'm the first gig of the day. So, hi, I'm Varun Singh, CEO of CallStats.io. We've been doing this for a while, since 2014. Actually, this was the place where I first came and presented what would become the company, because a lot of technical people, I gave the pitch of what would become the company. People said, yeah, that's a smart idea. We would love to use it. And because of the good feedback, we went and did this. So that was 2014. I was back here in 15. And the last 3 years I've not been here, but I met Carol recently over the summer, and she said, oh, well, you should come back and talk again. And we said, oh, we are indeed launching a few new features on our product, which would be exciting, especially AI related. So we put in a few talks, and here we are. So these are some claims to fame. We were recognized by Gartner a couple of years ago as an emerging company. I've been also part of the standards, especially the W3C, which is leveraged immensely by the product that we built. The co-author of the Statistics API, and everything that we do is leveraging this API and other web APIs. So when we started, and this slide was there in 2014 as well, one of the things that we noticed at the time when people were measuring or building video products, a lot of it was linear. Like they would put the product out, they would monitor their own product for things, but typically when a problem occurred, they would actually get input from the users, and when they would get input from the users, they would get reports either by email, Twitter, so on and so forth, and they would analyze the traces. They go back, they figure out what the bug was, fix the bug, and then deploy. And that kind of works if there are bugs, but sometimes the issues are much more complicated. So for example, you might be using a certain Android device, maybe a feature phone, not the high-end phone, but a mid-range Android device on a network in an emerging market, on an app that was recently updated, right? And there are so many things there that the chipset on the device might be underperforming, the network might be doing something different, and the app might have rolled out a feature that is causing performance issues, right? So there's so many issues in this that could be tackled. And one of the things that happens then is, especially if you're trying to do high-quality video communication, then if you're trying to do, let's say, 4K video on a feature phone, it might not work, especially not because the phone might not be able to do it, just that the network might not be able to carry it. And there's no ideal fix for this. What you need to do is then find the optimal quality. And so that's what CallStats' vision was, to actually take all this input and be able to adaptively apply fixes to an app without having to write much code for it. So we started with collecting data initially, so that was 2014, 15. We are a SaaS product, so we collect a lot of data, and basically we can learn from one product and apply learnings from one product to another. So we're at this point in time where we have about over 200 services using CallStats.io, and especially for the United States, we have a lot of data that can be leveraged already by new products and features that come on to CallStats.io. What it also means is that we have integrations with a lot of major providers. We're integrated into platforms, we're integrated into browsers, we're integrated into products of open source. And if you have a product and doesn't have CallStats.io, you should contact us. So taking a step back, CallStats, as its main value proposition is quality of experience. We measure quality of experience at scale. There's a $1 million slide because it's actually existed on every slide deck that I've ever presented since 2014, including the investor slide decks. So great shout out to Geek and Poke. They did a very good job of explaining how latency affects communication and how that's a measure of quality in some sense. So latency alone is not sufficient, because latency just means that you will have like a walkie-talkie type of conversation sometimes. But it also manifests in like audio video being out of sync, where you hear the person and the mouth moves independently. There can be situations where the audio is ahead of the video, which is really annoying. If what we really like, especially if you have audio video out of sync, is video plays before the audio, partly because humans are really very tuned to seeing lightning and then hearing lightning. So because of that, every time we see Netflix go, if we see the person speak and then hear him speak, that's probably okay. But if you hear them speak but don't see the motion as yet, that's really annoying, because your brain's not able to compute what's happening anymore. So taking these things into account, we started to build this into our service. And what I'm going to lay out is something that you guys can also use in your products. The main thing in building quality of experience models is patience. It's not complexity. Typically, you can start very quickly to do something, but you just have to like work through all the edge cases, all the scenarios, which requires much more patience and time to get it right. So for measuring quality of experience of a call, that typically means that you have to take the call experience into account. So the call experience is typically from the time you start speaking till the time you hang up. But that's not the only thing that you need to take into account, especially with the web and with Google pushing the web so quickly, and like their adherence to like reducing latencies on page loads also means that setup times across the internet for calls has to be also very spiffy. They have to be like really quick, especially if WebRTC or web-based real-time communication is going to be part of like mobile apps. You can't, like people on the mobile are not very, they're distracted. So if it takes a lot of time to set up a call, they're going to just switch out to another app or service because it just takes so much time to set up a call. So call setup is like really important part of that experience. Then there's always the case like on Skype and similar, at the end of the call, you get a menu of questions like, hey, how was your call experience? Was it good or was it bad? You get 5-star ratings. You can give audio, video. So collecting that also helps, because getting raw data about what the experience was in the user's own words kind of helps, or at least something similar. And overall, if you measure user experience, it should start from the time that someone launches an app all the way till they close the app. So all parts of it, like page load, app load, call context. So for example, if you're on Hangouts or similar, where you get a URL and you click it, the call typically starts immediately, like the same thing with Zoom and so on and so forth. So you have to take those contexts into account. If you're on HipChat or Slack or something similar, you're in a room and you actually expressly choose who you're going to give a call. So you click on a name and you say, like, I'm going to call this room or a person. So those are important aspects of it. And for us, we collect statistics across the whole pipeline. So we not only collect statistics during the call, but before the call and at the end of the call. And the more exciting part for us is that when you have calls, it's different from web pages, because in web pages, there's only one person interacting with the web page, right? So you can actually model it very easily. It's a client-server interaction. When is the client asking for data? When is the page loaded? What is painted? What is it viewing? And now you have like all these eye trackers and so on and so forth, so you can actually know when things are loaded, what people are looking for, and optimize the page. But for calls, that's more complex, because there are typically at least 2 people in a call. So in this case, Alice and Greg. And there can be more people in a call, like there can be multi-party calls with 5 people, 10 people, hundreds of people. But when you measure user experience, it's a good question to ask, like, how do you measure Alice and Greg, right? And what does it mean when the call ends? What is the score that you want to get out of it? Like, what is the overall score? And how do you measure that? Because if you take Alice and Greg in entirety, then you would just get a weird score, because you take Alice's score and then you take Greg's score and you divide it by 2, you get an average. That might be like the simplest thing to do. But typically that's not the case, because people are speaking. And quality of experience should only be about like people listening, right? Like if I'm speaking and if you can't hear me, then that's an issue. So in this case, when Alice is speaking, we measure what Greg is listening. And when Greg is speaking, then we measure what Alice is listening. And that just means that it looks like something like this. So you have Alice, and then you see what Greg's receiving and what Greg's comprehending out of it. And then when Greg speaks, then what Alice is doing. So in this case, it's also simple because everyone's speaking for equal amount of time. You can easily have different scenarios where Alice asks a question, Greg answers, and then Alice asks another question, Greg answers, and then the interactivity is slightly different. And in those cases, that Greg's quality of experience would be the overall quality of experience of the call. And in this case, it might be more or less equal just because Alice and Greg are speaking equally. But this brings us to interesting phenomena because when you have bad networks or bad devices, that means that when Alice is speaking, either the network is dropping packets or Greg is Alice network is dropping packets, or the encoding is off, the device is dropping packets. So anything can happen, and in these cases what's going to happen is that Greg's not going to hear everything that Alice is going to say. And it also means that it might be possible, because you're not hearing anything, Greg might start speaking while Alice is speaking, which leads to crosstalk, which is also annoying because you might be saying something and you're speaking as if the other person's hearing, and then you start hearing someone else speak in between, and you're like, hey, just a minute, I'm not done as yet. And that leads to a worse user experience. And these things can be modeled very easily, especially if you have data coming in from across the pipeline. So these are just charts to show what is happening, because I have an actual real-world example. So these are 3 people in a call, privacy preserving username, so we don't know who they are, so we can just assume Alice, Greg, and Bob. Alice is the first one, Greg in the middle, Bob and at the end. And what it's showing, the gray areas are, I'm not sure if they show up really well here, but the gray areas are periods of time when they're disrupted. For us, disruption basically is a word that we use as an overarching term that means that either you had high packet loss, or you had high delay, or you had very low throughput, or like, the media pipeline buffed for some reason, or the jitter buffers are misconfigured. So anything in the pipeline that's broken, which leads to like the person not being able to hear the other person, is disruption. And in this case, what happens is you notice that for most of the call, and the thing that we moused over is to, like, for 8 minutes in the call, Greg is not able to hear Alice, right? So Greg, being the last person, is not able to hear Alice for most of the call, but can hear Bob, who's in the center, which is interesting because that's at the end of the call, Greg would give feedback that, for most of the call I could not hear Alice properly. That's something that you can go and investigate. And this helps building quality of experience models very well, because if you get that kind of feedback, you get like a closed loop at that point, because the system has identified issues, and then a person's actually given feedback, especially to verify or validate what was being observed. Another way where you will not get explicit feedback is if you can anticipate user behavior. So I noticed when we started the company that whenever I was on a video call, if I had a bad experience, I would turn off my video, I would turn off my audio, and then turn them back on, turn back audio on, keep it running for a moment, and then turn video back on, just as a way to overcome what I would assume is congestion. And one of the things that CallStats does is get user events. So if you press all these icons, we collect those events as well. So we know when you're doing screen sharing, we know when you're muting your audio, and then we started to contextualize it. We said, we can measure disruptions. We're getting these events. Can we go from correlation to causation, right? Because if we can anticipate user behavior, you have a disruption, and the user is going to switch off their audio and video, we know that they're going to be super annoyed, right? Because if it was just a temporary thing, they would not do anything. But if they turn off their audio video, that means they've had that experience, a bad experience. So we now know that this is actually also validated in some sense. And so this is a call that we went to, and we parsed our logs, and we found several calls. And this was the most interesting one, because this is multi-party. So there are 3 people in a call, and the gray areas are highlighted, and the purple bars are basically the events. So they're muting and unmuting, and muting video and unmuting. So what you can see is, in some cases, the disruption happens, and then someone does it after the fact. Some people do it during the disruption, and that just shows that when people are not happy with the service because of disruptions, they might try to debug it by themselves. And this just means that we have a way to measure quality of experience in a very validated mechanism. Another example of this is where the user feedback was exactly on point to what the call was experienced. So the person saying that I was on this call, and I kept having outages every few minutes for a few seconds. That's basically what it's saying. And if you go and look at user A and user B, you can notice that user A, the gray areas are the disruptions. The call is 40 minutes long, so significantly long period of time for a call. And the person's actually, what he's saying is probably correct, because we can notice that there were outages for a few 30 seconds, 20 seconds, every few minutes. And when someone gives you this kind of feedback, you actually again know that we can measure quality of experience, because now we have validations of how these disruptions affect user perceived quality. And there are other examples of this. For example, when we talk about video, there's something called frame stability, and that typically means that, especially in real-time communications, not true for Netflix and other types of things, where you always want high-quality video, or whatever quality of video that you started with, you just want that quality of video, and you have buffering to like compensate for that. But for real-time communication, sometimes that's not possible, because you might be like driving and you're doing video calls, and you might not lose connectivity, just that your bandwidths might be lower or latencies might be higher. And sometimes to compensate for that, you might actually lower quality of video. So typically the thesis goes that whenever you want to reduce quality, you reduce quality in steps. And if you want to upgrade quality, you again do that, and like you do it quickly in shorter time span. But you should not oscillate at any given time. So you should not basically go from doing high quality video to low quality video and back to high quality video in a very short period of time, because that frustrates users immensely. But if you do what we call slow degradation, that means that you go from high quality and like over a few minutes go down to low quality. That's much better for the visual perception. So in this case, like for example, you can see like at the beginning of the call starts at a very high frame resolution. It starts at 1280, drops all the way down to 720p, stays for 720p till like almost the end of the call, and then starts to oscillate again. And this is another example of frustrating user experience, because for majority of the call was at 720. There was, like if it had remained at 720, it was not going to be bad experience at all. But in the middle or towards the end of the call starts to oscillate, which would like reduce the quality of experience. So these are all charts from callstats.io. So we're going to take a step back, and we're going to like actually look at some of our observations from measuring billions of minutes billions of events per month. Just to give a sense of where WebRTC is at today. And the main thesis there is that it's actually ready, has been ready for a while for prime time. So one of the things that you notice with audio, for example, is so we collect a lot of data and then we aggregate it. And this is 2 months of data aggregated. So the blue line's from July and the purple's from August. Like you can see that the 2 months are fairly similar. And this is an average of averages, right? So we took like average throughputs or median throughputs, and we basically took all the calls and plotted them on as a frequency plot. And what you notice is that actually 70% of the calls globally are about 45 kilobits per second, which is quite decent for audio. You can basically do on Opus pretty much anything at 45 kilobits per second. And that's your median. And majority of your calls, like almost 80% of your calls, 70% of your calls are in that region. That kind of works very well for us. Then the same thing for average throughput for video. You want to know typically what kilobits you can do. So the median is, of course, at 1250, which is above a megabit. That's also really good. That means that you can do 720p virtually anywhere in the, at least at 50, at least on 50% or more of your sessions, you can do 720p. That also means your desktop experiences and your mobile experiences can be much better than doing like low quality video. And then there, of course, like you can see like the 0 to 200 kilobits per second, that's about 20% of your calls. So that's also significantly challenging. That means that you need to, as in 20% of your calls are going to be in sub 200 kilobits per second. That means you need, as a developer or an operator, needs to understand how you're going to give optimal quality of experience to those users. Does that mean that you're not going to do video, or if you're going to do low quality video, what is it going to be? And especially trying to figure out very quickly if you're in this part of the curve or that part of the curve. So very simply, you could do like you detect at the beginning of the call, like what's the bandwidth, and then you detect that the bandwidth's really low, just start with a low quality of experience to begin with, and if it improves, then you upgrade them over time. As I said before, like most of your quality of experience is dependent on round trip time typically, because if your round trip times are high, you might even have high jitter, which leads to like other consequences. Either your jitter buffer becomes really large, you can have audio video out of sync, you can have frames drop because they're not played out in time, which leads to other artifacts showing up in your video and audio. And those are always an interesting issue to resolve. And with WebRTC, over the last few years, we've seen that two types of topologies emerge. So you have the peer-to-peer, which is what it was built for initially. And then you have the star or the bridge configuration, where you have a bridge or a middle box which collects, which gets all the video streams and the audio streams, and then either composes them as if it was an MCU, or as a selective forwarding unit, as an SFU, or has cascaded bridges where you connect to the nearest bridge and then they decide to send video. And typically these two things is, one is a mesh topology, the other is a star topology. And what we notice is that in the case of peer-to-peer, which is the blue line, this is CDF, so 95 percentile RTT for each session. You take the 95 percentile, that means it's the 95 percentile is the last top 5%. So the values are only higher than this value. That's how you would read the chart. And you can see like for 20% of the calls in the peer-to-peer case, the RTT is really close to like 10, 20 milliseconds. That means that people are either in the same city or same region or same enterprise typically. And the other thing that you can notice is that the infrastructure-assisted topology, so you can see the gray one, which is the turn servers, and the purple one, which is the infrastructure. So when the turn servers are used when you have firewalls that you can't navigate through, and what you see is that the peer-to-peer generally works very well. Like it has lower RTTs because there are fewer people in a call. People are geographically typically close to each other, so definitely not an issue. Then when you have so the most interesting thing is in this one. So as you notice that the gray line is basically a turn server, right? And turn server, as you see, like for the first 50% of the calls is mimicking close to peer-to-peer, and then suddenly it moves off and starts behaving as if it's an infrastructure-assisted tech. So basically the purple line is always doing worse than the peer-to-peer, partly because your servers are placed wherever they are placed. And if you're on Amazon, they're placed wherever Amazon data centers are. And they're not everywhere, right? So for example, if you're in Africa, there's not yet an Amazon infrastructure there. Until most recently, there wasn't one in India. So basically, your calls were going to things like Singapore or Hong Kong. And especially two people in India would talk to each other. It would have to go if there was no way to connect directly between those users. So yeah, we understand that the bridges are further away from each other. So if there are people in Australia or Singapore, they might just land up somewhere. But what we found unique was the fact that the turn servers were not, like, they were either close or further. So we started looking at, like, this seems weird. Like, why are we seeing an S-curve? Like, why would you suddenly dramatically see a shift that way? And so one of the things that we also did was we have our own turn servers, and the way we use those turn servers is something called pre-call tests. So one of the features that we offer to our customers is to know before the call if the call is going to be good or not. Right? So we run pre-call tests in the background. So if you're a Slack or similar, we run like basically, or a call center agent, we are running these checks in the background which are doing like 20 seconds of throughput, RTT, jitter tests in the background every 5 minutes. And we're collecting data, right? So like if you're not using any video call at that moment, it's running these things. It spikes up your bit rates every 5 minutes to like maybe 10, up to 7, 8 megabits per second, and then backs off. And one of the things that we noticed was that relative to our infrastructure, which is the purple and the blue lines, the peer-to-peer was always better. Right? So we know where our servers are, we know where the users are, and our servers are nowhere close to where most of the users are. Fine. But what we also noticed is that the bridges at some point were worse off than us. Like the turn servers that people were using were worse off than ours. So our turn servers are closer than other people's turn servers. Like all our customers put together, like 50% of the turn servers of our customers were in locations outside of ours. And that was interesting because without that data point, we did not know what the problem was. Like we could just assume that people were far, like the calls were further or people were further, right? So if there's a person making a call between Australia and United States, the RTT is going to be high irrespective of whatever you want to do. So in this case, 90% of the P2P calls were close to each other, were better than ours. And in 70% of the cases, they were worse. And why was it important? Because one of the things that we noticed was the quality for people on continental calls, so people where everyone was on the same continent, was much better than people which had intercontinental. So you can see the relative distribution. The objective quality score is between 0 to 3. 3 is better, 0 to 1 is bad, 1 to 2 is okay, 2 to 3 is excellent. We are very, very conservative in giving people 3.0 scores or even above 2 because we think that everyone's quality needs to improve irrespective. So we don't want, like generally our scores closer to 2.1, 2.2 is really good because we hope that technologies are going to come in the future which is going to make the networks better, and we can't give people 2.9 score and then still hope that the new technologies also give you a 2.9 score, then what would be the relative impact of a new technology? So the threes, today the highest score you can get is about 2.5, 2.6, but not higher. So you can see that the purple bars, which is continental, they're more to the center, more of them are doing 2 and above, which is really good, or more than 1.5. And in the case of the blue ones, they're actually struggling, as in most of the calls are really bad. So we basically had a very simple question to ask. Is the infrastructure placed correctly? And if not, what can we do? So what we came up with is a hairpin metric, where basically our thesis became like, it is possible that two people in India, their calls are being routed to outside India. Right? That was a very simple thing that we could say because there was no infrastructure in India. But then the next question was, how far is the call being routed to? Is it only going to Singapore, or is it going to Hong Kong, or is it going to Japan? Is it going all the way to the west coast of United States? Right? Because that's where most of the infrastructure is, because people are not deploying it everywhere. So how big is the problem? Where is it occurring? And number of sessions that are hairpinned. And today, what we define hairpinning, we could do it at a country scale, but it's more interesting because the infrastructure is not everywhere. It's mostly continental. What we're looking for is that if the calls are being routed outside the continent. So if there are two people in Asia, and the call is routed to a server which may be geographically misplaced anyway, like two people in Kazakhstan making a call, and the call goes to Singapore, it's not hairpinning for us because, well, there's very little options in this case, and we don't want to identify problems which cannot be solved. But what can be solved is that if that call is getting routed to the east coast of the US, then we should be able to bring that call back in and identify it. So what we noticed is that 30% of the calls in Asia and Oceania are being routed to the US, and 50% in South America are being routed to the United States. And 10% of most calls in most areas are being routed to the United States. So even in Europe, we're seeing 10% of the calls go to the US. Mexico, well, that's probably valid. And the only place where we don't see this behavior is Africa, because most people in Africa probably, most people running services in Africa, intuitively understand where the infrastructure is, and they actually just fail. So if you can't actually make a call between two people in Africa, they just say, we're not going to use a server that goes out. So 10%, what we see is that 90% of the calls in Africa are peer-to-peer, and only 10% actually leverage servers, and most of the servers are either in South Africa or in Nigeria or some places. And they are either maintaining those data centers themselves, or they're using data centers that already exist there. And very small percentage, almost 5% of the calls, are actually going out of that continent somewhere else on our service. So I'd like to close with that. I have another talk in 30 minutes where we're going to talk about how we are using AI to find some of these issues, because as network engineers, we've actually not run to the end of the thesis or hypotheses we can make, but it's just not reaping enough dividends to us. When we come up with hypotheses and go look for them, sometimes we only find some small, insignificant numbers, but we know there are bigger problems out there. So we're now using AI to figure those out. So the next talk is more about how we're not using our experience as network engineers, but letting the AI lead us to hypotheses that we then try to prove as network engineers. If you have any questions about this, I'm happy to take them.
Thank you. You made a statement that sounded a little surprising to me, that your metrics indicate 10% of the calls from Europe are actually going to the U.S. and back. Europe would seem to be infrastructure dense, if you could say it that way. So you have any thoughts on why that might be occurring?
So there are two parts of it. One is load balancing, right? So invariably, some services are U.S. dominant, and they have some infrastructure in Europe. And when that infrastructure is fully loaded, you're not going to drop that call. So you would end up going to the US irrespective in those cases. One is that we see quite often, but that's one part of it. The other is there are people who do not realize where their end users are sometimes. So they might be basically either only US-centric, and they have only infrastructure in US. Snapchat's a very good example. That's how they did it. For almost until they went public, most of their servers were in the US and some in Europe. And as a consequence of going public, they did state that they got this $400 million or $1 billion deal with GCP, and then they said they were just going to scale. So you see some of that, and that's also true vice versa. There's actually also situations where we see US calls being routed to Europe, and that might be because of GDPR. One, that's because there might be one person in Europe, and the server chosen is Europe. And there might be services which are GDPR compliant and just want most of their calls to be routed through Europe. And then we see some of their calls move off for example, I might be on a service which is mostly European-centric. The service knows that I'm mostly European-centric because I want GDPR. And when I'm in Chicago, they might have to route my call just because they don't want to take a chance of figuring out that I'm suddenly roaming. And they just might So there are like these situations which maybe for political or other reasons they are being routed differently. But I think predominantly it's because like some people don't realize where the end users are, and they're mostly focused on those specific areas.
Thanks for the context.
Varun, how does this change where quality of experience is almost like determined a bit more by the software layer in the application? For example, I was writing something the other day about video calling or conferencing apps where you might have something trying to work out which part of the image is most important. And you basically concentrate the resolution on someone's face, or there's some sort of annotation where you say the most important thing in the scene is the city on the horizon, not the people in the foreground.
Right. So the good thing for us is that at the moment we're not capturing video ourselves. So we don't actually look at the scene ourselves. And the quality of experience is actually inferred by metrics that are being rendered. So basically, if someone's blurring the background and only doing the foreground or vice versa, they just do it as a pre-processor step before they feed it out, right? So at that point, when it goes into the encoder, outside the encoder, into the transport, they're not going to see any artifacts as a consequence of it. And therefore, none of the metrics are going to suddenly like blow up because of that. If, as a consequence of blurring, you actually have artifacts appear on the far side, then we would detect it. And then it would be a very good question if like the artifact is because of network or because the blurring was incorrectly managed.
Yeah, I suppose I was thinking more, not necessarily about artifacts, but more if there's somewhere in the end-to-end path, something says, if you have limited resources, concentrate on this bit.
Yeah, so that's not a problem for us because our main consequence for that is, it goes back to what I said about frame stability. As long as you do not intrinsically like do something like blur, unblur, blur, unblur, then we would catch it, and then we would be like, I'm going to penalize it. But if you don't do something like that, it's consistent. For us, the quality of experience is all about consistency. Like, you may do whatever tricks you want to do, but as long as you start with something and stay the course with it, we're happy with it. But if you start like changing out your tools in the middle of the call, and that is going to affect, because as an end user, like you blur my background and then you unblur it and then you blur it back, I'd be super annoyed. I'd be like, what?
I suppose you could have a webinar where you go from slide to talking head and then back to slide again.
Right, and in those cases, as I said, that is taken care of by the Alice and Greg situation I showed before. Like, we know who's speaking, what are you speaking to, and we also know in multiple scenarios, it's not necessarily, I might not be the most important person speaking, and someone's actually watching someone else, like my slides might be the most important thing that you're focusing on, as opposed to like watching me speak, right? So.
Yeah, actually, it was a good post someone put on Medium yesterday about one of the issues with some video conferencing applications is they focus on the person speaking most or speaking most loudly, who's not necessarily the most important or most valuable.
Yeah.
We need to go. Thanks for that talk. I think we need to move on to the next presentation.
8 minutes.
Yeah, thanks so much. And we'll hear more from Varun in just a few more minutes.